Mr. Pham, is this for Tech 2?
Yes, that's for Tech 2. You
Okay.
already said it. If you are on a new Tech 1, go to Mr. Tai Zoom.
Okay.
Okay, so basically we start with the digital, and this time we try to go into the detail. Something basically technicians do not quite really need at work. However, that will be helping for your knowledge, helping for your, if you go to the college or go to the university, and they will be go to the detail. Okay, that one we already done. Okay,
I can learn to understand you much better if I can get familiar with the way you talk. I need your permission to help.
no problem. Okay, that one we already done. Okay, everything done. Okay,
Are you recording?
yeah, I think I already recorded.
Yes, you did.
Is it right?
Yes.
Okay, thank you.
You're welcome.
Okay, now. Okay, so first thing they say, do they want to converting binary to the decimal? You understand you're using 1 time to whatever power of whatever number. Okay, this one I think you already get the answer last time. So I can give you the answer here. Okay, make sure you get the right answer. And the second one, they given you the decimal, they want the binary. The number A already get answer here. B already get answer. And now I given you number C. And number D. If you don't have it, the answer, copy it. Anything confusing or you don't know what to do, bring it up. Okay, so we're done on this page, right? And then they're talking about binary addition. So they try to adding 0 to 0, you get 0, 0 to 1, get 1. 1 to 0, you get 1. 1 to 1, you get a 0, but you carry 1. Carry 1 means you adding 1 to the next column. Now you do it for me. Number 1. Convert following binary to number in to the decimal. That's what we don't really quite needed. So I given you the answer. We supposed to go to the next page. Okay, Now add the following binary number. Quickly try the best. Can you get the answer?
We went through this last week, I think. First answer is 110.
Okay, just let me know.
Yeah, we went through. Yeah.
And then binary subtraction. Okay, so 0 minus 0, you get 0. 0 minus 1, you get 1. However, we need to borrow 1. Borrow 1 means subtract 1 from next column. Okay, and the example A, B, C, D, we already done or not? Okay, that's what I given to you. Okay,
Yes.
go now. Complement of the binary number. You understand in the computer, they have to deal with either positive number and also the negative number. So they get a two number system to deal with the positive and the negative. That's what they call a first complement or second complement. So in the computer, either system can be built. They not both. Okay. Normally they using second complement. So first complement binary is found by changing on 1 to 0, on 0 to 1. That's very simple. And second complement, then you want to find the second complement. You have to find the first complement. Then you add into 1. That's what given you second complement. Okay, this one we done or not done?
We did.
We did?
Yeah, I think we did.
Okay, that I given you. Make sure the people get the right answer. Okay? And now we're talking about the sign number in digital systems so that the computer must be able to handle both positive and negative number. A sign binary number consists of both sign and magnitude information. The sign indicates whether a number positive or negative, and the magnitude is the value of the number. Okay? There are three forms in which sign integer number can be represented in binary sign magnitude. Okay? First complement, second complement. Of this, the second complement is the most important, and the sign magnitude is the least yield. Okay, non-integer and very large or small number can be expressed in floating point. After completion date, we don't care it now. Okay. The side bit, leftmost bit is a side binary number. That is a side bit. Any depending on how many bits you get. In this case, we're using 8 bits. Then on the left mode here, 0 will be for positive number. 1 will be for negative number. Okay, that is the side. Okay, the decimal number minus 25 will be look like. First thing, the number 1 here, telling you the number will be negative. Second here, from bit 7 up to 0 here, that will be the magnitude. Okay, so if you do a calculation, this one, they will be 25. Okay, and the number 1 telling you they will be negative 25. Okay, notice that the only difference between plus 25 and minus 25 is the side bit. Because of the magnitude bit are true binary for both positive and a negative. Okay, in the sign magnitude form, a negative number has the same magnitude bit as the corresponding positive number, but the sign bit is 1 rather than 0. Okay, this is normal that happen this way. Now we're talking about first complement. Positive number in first complement form are represented the same way as the positive sign magnitude number. Negative number, however, are the first complement of the corresponding positive number. For example, using 8 bit, the decimal minus 25 is expressed as the first complement plus 25. Okay, that means 0, 0, 0, 1, 1, 0, 0, 1. If you calculate into the decimal, then you will be see that the value will be 25. Okay, and now they put the number 1 on the side but here, telling you they will be minor. However, the value here, you see that 1, 1, 0, 0, 1, 1, 0. How come you get this number? The first one
First
telling you
complement.
negative. Okay. However, it's a different from the last time the magnitude bit negative. This is the first complement. Okay. So the number 1 telling you negative number. How come you get this number? This is the number 21 right here. 11001 25. How come you get 1100110?
Changing zeros for 1 and 1 for zeros.
Perfect. You have to convert into the first complement. First complement means 0 tend to 1, 1 tend to 0. Okay? In the first complement form, a negative number is the first complement of corresponding positive number. Second complement. Positive number in the second complement form are represented the same way as in sign magnitude and first complement form. Negative number are the second complement of corresponding positive number. Again, using 8 bit, let's take the decimal number minus 25 and express it as the second complement. So you know 25 will be 11001. That's the number 25. Okay. Invert 8 bit, then you adding 1. That's why you get 1, 1, 1001111. So, in order to find the negative number of number 25, okay, first thing, the first bit must be 1 for negative. And the rest of the bit here, you must be converting to second complement. You get the second complement, get the first complement, then adding 1. Okay, now express the decimal number 39, 8-bit number in the sign magnitude, first complement and the second complement. That means we try to do all of the 3 things I just bring it up to you. Now, first try 8-bit number 39, 100111. If you're doing calculation, you get 39. Make sure I'm remind you, okay? If you not understand or you don't know why, you must be asking, okay? Now, in the sign magnitude form, minus 39, it produce changing the sign bit to 1 and leaving the rest here, same thing. That means the first one will be 1 and the rest of the bit will still be 39. That for sign magnitude form. Now, in the second, okay, you understand in the second first thing, you get number 1, right? Negative. Then you must converting 01001111 here to the first complement, changing 1 to 0, 0 to 1. Okay? And now in the second complement, okay, then the first number must be 1. Then the number 39 value here, okay, you need to converting into first complement, then you add 1. That's why you get second complement. Okay? If you are able to understand, can you doing for me plus 19 and minus 19? Same way. That means first thing you have to tell me what the sign magnitude form, okay, and what first complement form and the second complement form. This one we not done, right?
No, not yet.
Do it now
Thank you.
to see how many people able to follow it, or you still don't know what to do.
0010011. It's positive 19.
Okay. Is
Yeah.
it 000 10011?
Yeah.
That's for positive.
Right.
First complement, minus, you get 111, 01, 100. The thing is sometimes I can get a mistake and let me know. We can work out. And in the second complement, the answer will be 111, 01, 101.
Yeah. You don't have assignment magnitude?
Magnitude, they are not answer here. So basically you get a 19, right?
Yeah.
If positive, the leftmost bit will be 0.
Yeah.
If negative, they will be 1.
Right.
Value will be no change. That may be too easy, so that's why I'm not giving the answer here.
Yes.
We try to finish this thing. I don't want to take too long. If you already copy it, let me know. You need it, the thing is you must be doing your homework. Okay?
Yes.
Okay, determine the decimal value of this side binary number expressed in side magnitude. You get a number 100100101. Okay? First thing you can say, this number will be positive or negative.
Negative.
Negative, the thing is
Negative.
start with 1. Okay? So now, what they try to do here, they try to see the value of this number. That means 0010101. Okay? If they doing a calculation, they get number will be 21. The side bit is 1. Therefore, decimal number minus 21. Okay, if you have already done, quickly telling me related problem. Determine the decimal for 01110111.
119.
Uh-oh, they did not give an answer. Okay, let's see. I go invite that. Oh man. Let's see, that one we already done, right? Okay. Let's see.
19 as well. Positive.
119.
Okay, let's see. The answer will be 19, right?
119.
119.
119.
Okay. I don't have an answer here. First complement. Decimal value. Positive number in the first complement form determined by summing the width in on bit position where there are 1 and ignore those positions where there are 0. Decimal value of negative number, okay, are determined by assignment a negative value to the width of the side bit, summing on of the width where there are 1 and adding 1 to the result. We see. Now, this is the example here. Decimal determine decimal value of side binary number expressed in first complement A, then B. Now, solution. Number A is positive, correct? The thing is they start 0 right here. So, the bit and their power of 2 weight of the positive number. That means they calculate from bit 7 here to the 0. So minus 2 power 7. That means the first one, they 0. So that's why 0, you get 0, you don't care. Now you care about any one will be 1, 1, 1, 1. If you're doing a calculation, you can get 16 plus 4 plus 1 plus 2 plus 23. The bits and their power of 2 weight for the negative number are as follows. Notice that the negative side bit has the weight of minus 128. That means the first one here will be times 2 to the power 7. However, they negative. Okay, so that's why you get minus 128. And the next one, you get plus. This is the magnitude, okay? 64, 32, 8. You get minus 24. Adding 1 to the result, the final decimal number will be minus 24 plus 1. And the answer will be minus 23. Okay? So now try to see you can get a related problem answer for me.
So Mr. Fan, for positive number, we do not add 1.
Now, positive nothing.
Right. But for the negative,
They deal with the negative.
only negative. Okay, got
Yeah.
it.
The thing is they need a first or second complement to deal with the negative. No problem for positive. If who get a related problem answer, let me know. Who get the answer?
Minus 60.
No answer. Just take care.
Minus 20.
I don't know. Second complement. Decimal value of positive and negative number in a second complement form determined by summing the weight in all bit position where there are 1. Ignore those where there are 0. The weight of the side bit in a negative number is given a negative value. Okay, so they given you 2 examples here. First thing, they want 0, 1, 0, 1, 0, 1. I know this is a positive number. Okay, so first thing, you calculate by take first one minus 2 power 7 here. Okay, 2 power 6. This is the value. If you adding 64, 16, 4, 2, you get 86. And 0 here tell you positive. So that's why not 86. And now, only thing we really deal with a negative. The bit and their power of 2 weight for the negative number are as follows. Notice that the negative side has a weight of minus 128. So that's why you can do the same for 60. Okay, any number. Like you get a 1, 0, 0, 1, 0. So that number will be equal 32 plus 8. Okay, 40 plus 2, 42. However, the first one you get a minus 128. And finally, you come up with minus 86. This time I try to give you the first to be example. Okay? If you understand how the example works, then later on, no big deal. Okay, binary to hexadecimal conversion. That's the easy one. Okay? They given you the binary and they want to convert into the hexadecimal. The thing is that will be using in the computer. Computer really deal with only binary 0 or 1. However, the human, they enter by using hexadecimal. So that's why we have to know how to convert it. In order to do from the right to the left, divide each group into the height. So I can give you right here. Okay, from the right to the left. Okay, divide by group of 4 bits. So 0, 1, 1, 1 from the table. That's the 7. 0, 1, 0, 1, number 5. 1, 0, 1, 0, number A. 1, 1, 0, number C. So the answer will be 3. Let's see. CA57 in hexadecimal. And another one here. Okay. Easy for you to get through it. Number 9. Number 6. Number 1. Number F. Number 3. So that's why you get 3F169. Okay? Then you're doing a related problem for me. This one really you must know. The thing is, when you start doing the lab, that will be using all the time. I can look into that. I can tell you right away. First one, what number you get? 1100.
D.
8.
The next one, 1001.
9,
9.
9.
Perfect. And the next one,
7,
7.
11. Right?
7,
7. 011. The next one,
F,
F. And the last one,
4,
4. Perfect. BCD conversion. Now again, BCD means binary code decimal. What that mean? That means the binary they working exactly the decimal. And you understand in the decimal, they get only number from 0 to 9 only. Okay? So if you want to converting decimal into the BCD, each digit in a number in a decimal, converting BCD, they are asking for 4-bit each one. Okay, now you see the example number 35. 35, first thing you converting number 3 will be 0011, 4-bit, and the number 5 will be 0101. Okay, and number 98, easy. Number 9, 1001, 81000. So now you know how to convert it from the decimal to the BCD.
Hey, Mr. Pham.
Relate problem 9673.
Hey, Mr. Pham.
Yeah,
I was just going to ask, is it okay? Like, I always go from right to left, and the reason I do that is because of that formula 2 to the n, and you always start 2 to the 0, 2 to the 1, 2 to the 2, and so forth.
you mean from the right to the left?
Yeah, because the formula 2 to the n starts on the right at 2 to the 0, and then the next one's 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, and so on. So that way, when, say like for the number 9, I would do like 1001, but I'm starting from right to left. Or it doesn't make any difference if you can just,
No, that doesn't matter.
yeah, okay.
Just tell me.
You answered my question. Thanks a lot.
Yeah, you just telling me what the number. Doesn't matter, you go right, left, or left, right.
Okay, thank you.
Okay, so 9673 to BCD. Easy, right? Number 9, 1001. Number 6, 0110. 7, 0111. Number 3, 011. Then you converting BCD to the decimal. Same way. Right to the left. Divide to 4
86.
bit. Okay, 10 equal. So A you get first one 011, 0 number 6. 1000 number 8, 86. And the next one 001 you get 1, and you get number 5, and you get number 3. And the last one here, you 40 you get 0, 7, 4, and 9. I don't know, I get the answer for you in the relate problem. Maybe it's so easy. I'm not given.
822. 2, 2, 7, 6.
Right, that will be number 6, number 7, number 8, whatever. Okay, you do job. Okay, now you adding BCD. I want to adding number 0011 to 010. So now you can see A right here. 1 adding 0, you get 1. 1 adding 0, you get 1. 0 to 1, you get 1. 0, 0. So basically you understand 011 number 3. Adding 010 number 4, you get number 7. Okay, number B. Now, how can we get number B? 1 adding to 1, you get 0. Carry 1. Carry 1 adding to 1, you get 0. Adding to 0, you get 0. Carry 1. 1 adding to 0. 0 adding to 1. Now, 1 adding to 0, you get 1. 1 adding to 1, you get 0. Carry 1. 1 adding to 0, you get 1. 1 adding to 0, you get 1. Okay? And the second one, 0 adding to 1, you get 1. 1 adding 0, you get 1. 0, 0 here. Okay, now, if you're looking on the first number, what's the number? 23, right? That number 2. That number 3, 23. That number 15, 1, 5. Okay? 23 adding to 15. That's what you get, 38. Okay, C. 0 adding 1, you get 1. 1 adding 1, 0. Carry 1. 1 adding to 1, you get 0. 0 adding 0, you get 0. Carry 1. 1 adding 0, you get 1. 1 adding to 0, you get 1. Okay?
86 and 13.
Yeah, basically you get 99. 99. Okay, so if you're adding number D, can you get that answer?
Yep.
So the decimal number on the top 0, 5, 8. That means 850. 850. And you're adding to this number 7,
1,
1. And what?
4,
4. 471. When you're adding those two numbers, you're supposed to get 8, 6, 7. Okay? And the relate problem, I don't know. I get the answer or not. No. You do it. Now, giving you a little harder. So you're adding 0, 0, 1 to 0, 1, 0. 0, 0, 1 means 9. And you're adding 0, 1, 0 means number 4. The answer will be 13. Right? That's easy to recognize. Now, you see how they do. You see that? They say number 9 adding 4. You're supposed to get 13. 14. 1 adding to 0, you get 1. 0 adding to 0, you get 0. 1 adding to 0, you get 1. And 1 adding 0, you get 1. Now, this number here, 1101, we set invalid. BCD. You understand why invalid?
Yes.
Why they invalid?
It's greater than 9. The maximum is 1001.
Yeah, the thing is that number basically number 13, right?
Mhm.
However, BCD get up to only number 9. You don't have any number 10, 11, 12, 13, 14, 15. No. In this case, what to solve the problem? They telling you, if they not valid, you must adding to number 6. Okay? That means you take the answer here, adding to number 6. Okay? That will be given you 001, 0011, and number 13. Okay? The thing is you understand 9 adding 4 will be equal to 13. Okay, on this one, you must be do for me. A, B, C, D. Try to see how many people get the right answer. Whoever get the number A done, let me know. I will show you my answer. Okay, quickly. We get only one more hour. I try to finish everything here today. Okay, anyway, I given you the first answer. That is the first one.
Got it.
If you cannot figure out, spend more time to go through the example and try to do it. Okay, that B. C. D. Okay, you're not done. Copy. If you found I did wrong, let me know so we can correct it. If you done copy, let me know. We go tonight.
Mr. Pham,
That
I don't think I really understand about the adding. I mean, I understand that the number was greater than 9, but I don't really understand about how you ended up adding the 6.
yeah, the thing is that is the rules.
Oh, yeah, it's always 6.
They must be.
Okay. Thank you.
No problem. Okay. Sometimes we have to follow the rules. Okay. What next? Gray code. You get a decimal binary. You want to something know about the gray code, you can read in here. I don't care. Okay. And binary here. And this is the gray code here. Okay. That is given to you. Now we really care how to converting binary to gray code conversion. If you get a number 10110 binary, and now they want into the gray code, the way to do. First thing, this number 1, you take it down here 1. Then you adding 1 to 0. Okay, you get 1, put in here. Then you take up 0 adding to 1. You get 1, put it here. Then 1 adding to 1, you get 0. We don't care about the carry. Okay? Then 1 you adding to 0, you get 1. That's a very easy one. So the gray code will be 11101. Now you must be doing A and B for me. The easy one. Do it.
1011101. 1 plus 0 is 1.
Make sure you understand. First thing, number 1 must be put it down here. Then you keep adding, 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 without any carry. They ignore the carry.
0 plus 1 is 1.
Mr. Pham carried the 1 or no?
No, no carry.
Okay.
If you're reading, they're telling you, this card carries. Ignore that. So, who get number A done?
111011.
We'll see. 111011. Perfect. Next
Easy.
one.
A.
B same.
11101. Ah,
B the same.
Great question.
Oh,
1 convert binary to gray code, okay? Now, converting gray code to binary. Okay. Now you get a number 110111. That's the gray. They want in binary. What can we do? Now, first thing you take 1 here, down here, 1. Okay. Then 1 you adding to 1. You get a 0. No carry, okay? Then 0 here you adding to 0. You get 0. 0 here adding to 1. You get 1. 1 adding to 1. You get 0. Easy. Okay? Do number A, B.
0,
I think this is a very, very clear. Only thing you want to learn or you don't.
1 plus 0 is 1. 1 plus 1.
Whoever get answer, let me know.
0 plus 0 is 0. 0 plus 1 is 1. 1 plus 1 is 0. Plus 1, 1, 1. Got it, but don't do
1010101.
1, 0, 1,
11001010.
That's the answer for A.
Yeah.
Think nothing can be more easy like this thing.
111 010.
Perfect. Okay. Go. Add key code. We don't care on that. If you want to see the table for the American Standard Code for information interchange, go to Google, typing ASCII. They can telling you in the keyboard. They assign the letter A for how many bits and what the bit equal. Okay. Now we're talking about parity method for error detection. They must get the parity when they send the data from the keyboard into your account, into the center computer. The data sending will be a serial. Okay? Again, we want to make sure you understand inside the computer, they only working with the parallel data, not the serial. However, when they transfer the data from one place to the other, they must be using serial. The reason is binary in the computer, they using parallel. 16 bit, they need 16 wire. 1 bit for 1 wire. 64 bit, they get 64 wire. However, the serial data, they no matter how many bits, they need only 1 wire. So that's why they are only using for transfer data from one to the other. Okay? When they transfer it, they have to get a way to check to make sure for some reason 0 change to 1 or 1 change to 0. Okay? That make a big problem. The thing is when you transfer $1, you want to deposit $1. However, the other bit change to 1. So you risk. Okay? Or you can be losing the money. So that's why they get the parity. Okay? Parity, they get an even parity and odd parity. Okay? Now, you can see this is number 000. That means on 0. So if you want even parity, they must be adding to 0 here. The thing is, they looking for the number 1 in the data. No 0, that means no number 1. So that will be even. However, the next number 001, you get only 1 number. They not even, they odd. So the parity bit, they have to add in 1 to make it even. That means you get 2 1 even. And the next one, you get only 1. That odd, they must be add 1 to make it to be even. The last one, you get a 1 1, they already even. They must be at 0. That's for even parity. Now, odd parity. The first one, you get the own 0 here. they even. They don't have any number 1. They want odd, so they must be parity bit must be 1 to make it odd. Second one, 001. This is already odd, so the parity must be 0. Next one, 10, already odd, so parity 0. And now you get 011, even right now. So make it odd, the parity must be 1. That only talking about even or odd. They have to be using either one, cannot both. They are using even parity or odd parity. And in order to understand, you need to doing the example, I think. Okay, here. They want you to assign proper even parity for the following. Number A, what even,
Even.
what the parity
0.
bit,
Even.
what the parity bit,
0.
0, perfect. How about B?
1.
Perfect. C,
0. 0.
0. D,
0.
0.
even, they got to be 0. And the last one,
1.
Odd.
perfect. The thing is right now they odd, right?
Yes.
So you have to add 1 to make it even. That's the answer. That's easy. Now, that's really we need to go.
Hey, Mr. Pham, I didn't get that. Could you put that back for just a second?
Okay, put it back. We done on this one or not?
Just a second, please.
That's what you want, right?
Yeah, just a second.
Okay.
I got to play with it. I didn't really get that even odd stuff that good.
Okay, then I have to converting into my iPad. Okay. You done let me know. I
Yeah,
can.
I'm done. I'm done.
Okay. I need to stop share on this guy. Okay.
I don't know what it was, but I missed something on the even odd.
Okay. Let's see. I stopped that guy. Okay. Let's see. Share. Screen share. Okay, so we already done this one. You can see on the handout, I get a two file the same name, but one on the PDF, the other one on the PowerPoint. I say iPad. That means PowerPoint. The thing is we cannot running good on the PDF on the iPad, so I have to put up there so I can transfer to my iPad. Okay, see. Okay, on this thing here.
You were doing the even odd parity.
What?
You were going to go over the even odd parity again, correct, or what?
That will be go through the Boolean.
Oh, okay.
Okay, now you understand a variable, right? We already know. In the binary, okay, I say if at a variable, in binary, what I equal?
Zero or
I don't even know what you're talking about.
If I here variable in binary, what I equal?
Zero or one.
Yeah, you understand in the binary you get only the two number. They either 0 or 1. So in binary, okay, then I equal 1 or 0. Okay, so we can say if I not 0, then I must be what? Okay, now Boolean algebra basically they using to simplify the circuitry. For example, you want to design the circuitry, they get too many gates, okay, in that design. Then they cannot build it right away. They have to using the Boolean algebra to try to get the same similar thing, but try to get a minimum number of gates. That one basically you just understand why they need the Boolean. But we not using that engineer also. This is a two on, okay? Hard to do. So that's why later on they can do they using the same way, but they using the K map, Cagno map, okay? For any design, for engineering. Okay, now we go quickly go through here. First thing, you get A or 0. A or 0 equal what?
A.
1.
A or 0. Now, A can be 0 or they can be 1, right?
Oh.
It can be 0 or 1 this one.
So 0 or 0. 1 or 0. So in here, you cannot say 1 or 0. The thing is they depend on A. A0, you get 0, A1, you get 1. So the answer here, they must be equal to A. So that's why you see number 1. A or 0 equal A. Now, next one, A or 1. Remember, for the circuitry for this one, I given you example. Tie to 1. Okay. Now, if the circuitry, they say input connect to 1, where you connect to?
Where it says the 1?
Now, when you build a circuitry and you see on the schematic, they say connect to 1.
Positive.
Where do you connect that wire to?
Positive terminal.
5 volts.
You connect to 5 volt.
5 volt, yeah.
The thing is, in the binary, you get 5 volt and 0 volt. When they connect to the route, 0 here, means you connect to the
Ground, 0.
route. And that bring it up one thing. If you get a 1 adding to 1, adding to 1, adding to whatever, they must be what? You not carry anything. This is logical. 1 means you tie to connect to 5 volt. So even you can get a 1 adding 1 adding 1. Anyway, they all tie to 5 volt. So that means equal to what? 1 adding to anything must be equal to what? Okay, A times 0, easy one. Right?
Right.
Any time 0 have to be 0. A adding A. Cannot tell me 2A, okay? We don't have number 2.
You're on number 4, Mr. Bam?
We on number 5.
Oh, okay.
Number 4A times 1. If you are saying what A times 1?
It's A. 1 time anything is there, whatever it is.
A times 1. So basically, you cannot say equal 1. You cannot say equal 0. Depend on A. A0, you get 0. A1, you get a 1. Okay? Number 5, A adding A.
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 That answer will be A, not 2A. A or A.
A.
Number 6.
A.
The answer will be 1. I don't know why. Maybe typo, error, or whatever.
Hey, Mr. Bam, a little bit ago, you said that A plus A plus A plus A plus A is 5 because so then 5 and 6 should have the same answer.
Okay, now we get number 5 right now, right? A or A. Answer will be A. Number 6 will be duplicated. Okay, but that's wrong. Delete number 6. Same thing, A or A cannot be equal to 1. Be equal to A.
Right.
Okay, so delete number 6. Nothing to do with that guy. 7. A times A, not A square.
A.
A. Okay. Now, A not. Okay. Normally when you're reading on the textbook, they put the bar over. That means not A. What that mean not A? That means if you get the A0, not A will be what? A equal 1, not A will be
0.
0. However, we're using here, okay, instead A here you get the bar over. I using A with that side here. Same thing. They will be not A. Okay, now number 8. A and not A. The answer will be 0. Okay? The thing is A, if A equals 0 times not A equals 1, you get 0. And if A equal to 1, not A will be 0 times 0, you still get 0. Okay? And now A not. That means you get A here, 1 bar here, 1 bar here. Same thing I say A bar here. Okay? They go back to A. I given you example. If A is 0, okay, and 1 not here, you get 1. Not here, you go back to 0. Okay? So if you get a double not, they go back to original. Okay? Number 10. A or AB?
A, B.
A number 10. A or AB? Okay? The answer will be A. I prove it. A or AB? I can write down this way. A. Then you open the press.
Put a 1.
Then you get a 1.
1
Or
plus B.
B. 1 or with anything must be equal 1.
1.
1 times A.
A.
Okay?
Yep.
Now, number 12, we don't care. They equal A or BC. However, I want to emphasize here what you need to know.
What about number 11?
A or AB?
Oh, you didn't mean to write down.
They duplicate it.
Oh, okay. So you got to cross it out like number 6?
Yeah. Now, only thing what you need to know on this page is the Morgan law, the Morgan theorem. Okay? When you get the I, not I, that means H, Y. They put a bar, I don't want to put a bar, I put that the same thing. Not. Okay? I times I mean the product. Okay? determine the product time. Okay, and they will be equal not X or Y, not Y. That will be the sum. They converting from the product, okay, to the sum. Now, how? First thing, you want to remove that bar right here. Okay, then I come up to be not X here. Y will be not Y here. Only the difference here. This is the N. Now they converting to the OR. Okay? If you want to remove the bar over, if they are product, you must change to the OR. And the other form will be, you get this is the sum X plus Y. Now, what they want to remove that bar here. Take it out. So X will be turned out to be not X. Y turned out to be not Y. However, this is the OR. Change this one into here, they will be N or time. Okay? So that is converting from the sum into the product. Now, can you doing number A for me? Following that rules.
Hey, Mr. Pham,
Yes, sir.
I just want to ask a question. So the way to read that is not X or Y, and then it's equal to not X and not Y?
Yeah, they just converting. That means they want to remove the bar over.
Now, I was trying to find out the correct way to say it. The X
Okay,
and Y.
the correct way is under bar here, X turn out to be not X. Under bar here, Y turn out to be not Y. Only thing what I'm saying here, or here, turn out to be N. That means the sum here, adding, turn out to be multiply here. That's what they call a product. Okay? Sum to product or the product to sum. This is the product X times Y. You want it to be a sum. X turn out to be not X. Y turn out to be not Y. X times Y right here turn out to be lot. Okay? That converting from product to the sum or the sum to the product. Okay, now number A, you can get A or B. Okay? Or C. Time D. And everything over the bar. The problem is now remove that bar here. Who can get the answer for me? You're really good. Is it you know what to do?
Is it not A, not B, not C? What's that? Or not Y?
We don't have a Y.
I mean, not what's that? D, I mean, D.
D.
Yeah,
D. D.
yeah, not D.
Okay. The way that's correct, you good. I show you what to do. First thing you want to do is you break that one first. Okay? That means you can see you get a A or B or C and with D. So I break that first so you can see A or B or C, and this will be bar over. I break right here. And now right here is product. Then that must be converting to or. The D here must be converted to D not. Okay? And now you can see on that one, A come out to be not A. Or come out to be not B. Or here turn out to be not C. Then or. That is the answer. Okay? And number B, number C, then we already get the answer for you. Okay? Or whatever. You try it. Otherwise, I want to quickly go through this thing. Now, first one, they talking about logic gate. This is one really you have to deal all the time. That it will be inside the circuitry. First, logic gate they call AND gate and operation. Okay? When you say on this AND gate here, this is the symbol. Okay? The symbol for the AND gate. They get two input A and B. And the equation output will be equal A times B. Okay? When you're looking into that symbol, you have to know this is the AND. Okay? And the truth table, looking on the input output. Okay? This is the truth table. You get the input and you get the output. Now, on the truth table, if you get only two input, you get four combination. Okay? Using formula 2 power of n. Okay? And you get two input, 2 power of 2. You must get four combination, 0 and 1. So the first thing, you get 0, 0, 1, 1. Then the next one will be 0, 1, 0, 1, 0, 1, 0, 1. That is your input to this gate. Okay? And now the other one will be the output here. So 0, 0, A times B, you get 0. 0, 1. That means 0 times 1, 0. 1 times 0, you get 0. 1 times 1, you get a 1. Okay? So this is the truth table. Show you how did I get working. Now I given you example. If I given you one in here, one in here, what, why?
One.
One.
Okay, if you don't know, looking here, one here, one here, output one. Okay? So you get a 1. Now, if I get a 0 here, what output?
Zero.
One.
Zero.
If you don't know yet, I can tell
Zero.
you. Looking here, right? 0, 1, 0. Okay? Now, one thing you must know. What they say here, okay? For the AND gate, no matter how many inputs, but they get only one out. They say output is 1 if and only if all inputs must be 1. Okay? Now, if you get this and get here, 1, 2, 3, that will be A, B, C, and Y. Okay? So if I say A equal to 1, what output?
One.
No. Zero.
You have to say you don't know. Why? They already telling you. All input must be 1 in order to output to be a 1. So in this case, you say, I need to know what B. Then they given you B. 1. What output?
Don't know.
You don't know. Until you know if this is 1, output is 1. Can you follow that?
Yes.
Okay, now try to understand, okay? This really, we have to understand. I given you another example here. One, 2, 3. Okay, A, B, C. Y. Okay, if I given you a 0, what Y?
Zero.
No.
Don't know.
Zero.
Zero.
Perfect. Output must 0. The thing is you understand Y equal A times B times C, right?
Yeah.
1, 0, you time anything have to be 0. So
Yeah.
for the AND gate, 1 input 0, the output must be 0.
Zero.
You don't care about the other input. Can you follow me?
Yes.
Yeah.
Okay, now. If you get A to equal 0, output supposed to be 0. My question is, what should the input be? What you think? Input B supposed to be?
Don't know.
Don't know.
What input B? You can
It
get
could be a 1 or 0.
right?
It could be
It could be 1 or 0.
What can we say? Now you know a little more.
Zero.
In this case, then you must be saying I. What that mean?
Don't know.
Don't care. Okay? Now you understand one more thing. In the binary, you can get a 0, 1, and now you get a I. I, what that mean? I mean don't care. Don't care mean doesn't matter. They want a 0. Get it? That means don't
Yep.
care.
yes.
Okay, now. When you get this gate and get here, you apply a 0. you measure the output, you're supposed to get a 0. But they not. That means something's wrong, right? The thing is, you apply A0, then output must be 0. And now, you not get 0. You can get anything else, but not 0. So you see that is something wrong. For troubleshooting, when you get the output wrong, what you need to do is you have to check you get the right input or not. Okay? If you get the right input and the output is not working, that gate is not working. That is how to troubleshooting or isolation. Okay? So when you take the output here, you get 1 volt. Okay? We don't have a logic for 1 volt. Either they 1 or they 0. However, you say, I want 0, and I get 1 volt, something wrong. How? What you need to do is you say, okay, I go to check at the pin A, right here. How do we do? Normally, you will be using DMM, okay? A meter. Connect positive into A. Connect negative to the
Wow.
set to measure DC. Okay? Now, if you measure at pin A, you get 0. 0 volt. Then what? You tell me. What come up with?
Result 0.
But the output you want 0, but they not. So that's why you must be troubleshooting. And in order to do, you go to measure at pin A with the meter. And now when you measure, then you can get what you want or you not get what you want. In this case, I say, okay, you measure the MM and pin A, you get a 0. You must come up with something.
And the gate is the 40.
You fix the circuitry. You measure the output, you see wrong output. You take to a pin A, you want it to be a 0. You get 0. Telling me what next step you want to do. For correct thing, okay? You have to tell the people, this gate they not working. Why? The thing I get the input A equals 0. But the output supposed to be 0, they not. So that's why I need to change this gate.
Hey, Mr. Pham, do we need to check to see if we got a wire accidentally?
Who care? We don't know. We don't care about the wire or anything. Right now, we care about the logic in order to find the problem. When we go into the circuitry, then we're talking about that. But what I'm saying here, you apply input A0. Basically, for theory, you understand output must be 0. However, you take output, you not get 0. You want, you know some wrong. You're going to take a meter to measure at a pin A to see what logic, what voltage you get. Then I said you get a 0. Now, only thing is you give it to the assembler. Change this gate for me. Why? The thing is A equals 0. Output must be 0, but they not. Then this gate not working. You follow that?
Yeah.
Yes.
Now, the thing is, you know, I'm your boss. When you want to change this gate, I asking you why. Why you want to change this? You have to prove. You say, okay, I measure at the input A, I get 0. Output supposed to be 0, but I'm not get 0. So that get not working. That is one correct way to do. Now, the other thing, the other people say, I measure pin A, I get 0. Then I measure pin B, I get 1. I measure pin C, I get 0. Then you say the gate not working. So maybe they can send you back to school. Why?
Learn about gate.
As long as one of them is 0, you don't have to test the other two.
Perfect. That's what I say, don't care. Now, don't care mean either 0 or 1 doesn't matter. Why you measure it? This is a digital, okay? We not do extra work. Even you measure that, not hurt anything. But they're telling me you not understand. Why you say you don't care and you have to measure? You guys follow me?
Yes.
Okay. So that's why on the homework, you will be see I asking that kind of thing. Okay? That means I said I want output to be 0. And I given you input A equals 0. And I asking you input B and input C. You get 3 data to enter. You enter 0, you enter 1, or you enter 8. The right answer must be 8. I make sure you must be understand. I mean I don't care. I don't care mean I don't have to measure. Okay, that's it. Next week will be finished this thing. And we really go into what the technician need to do. Okay? That means next week we can get into the logic circuitry, analyze the circuit. Okay, calculate the input output and design some circuitry. Teach you how do we design the circuit. I'm giving you example here. Not in the how you get the upstairs, downstairs, and you get the light. Now, normally when you go upstairs, you turn it on. Okay, when you go upstairs, you can turn it off. You don't have to go in there. You see that? To turn off. That's what I want to design the circuitry. In order when you downstairs, you turn on. You go upstairs, you want to turn it off. You don't have to go in downstairs. Okay? On the upstairs, you turn on. Turn the light on. When you go in downstairs, you turn the switch. The light will be off. That means you don't have to go back up and down to turn it on or off. Next week, we'll be telling you the process. How do we design that circuit? Okay? And also telling you, you can see the light in the intersection. We design the circuitry to control the light when they turn red, when they turn green or yellow. When you understand, that is not a big deal. Okay? Any more questions?
Not today.
Try to understand. Okay? You will want to be a real technician. Then try to understand. Do not bring it up. We don't care. Different level in the continuing education.
Yep.
Teaching in a college, university more easier than continuing education.
You cannot say don't care.
Now you know you get don't care. Okay?
Okay.
Thank you.
Yeah. Have a good weekend.
Same to you. See you Monday.
Yeah.
Thank you,
See you.
Mr. Fan.
Thank you.
Thank you so much, Mr. Fan.
Yes, sir.
Yeah, very interesting to working on digital if you understand logic.